Hello, everyone, and welcome to our next podcast, number 2. And we were thinking of continue in the same track as we started last time, discussing the book from David Bohm from 1987, The Holographic Paradigm, and see that in relation to the very, very interesting speech made by Sir Roger Penrose on his 90th birthday, the 4th of August, where he has a specific example of him going to a Wimbledon game and seeing Federer playing and discussing this play in quantum mechanical terms. And what he said there was that Federer is creating reality with every smash on the tennis ball. And there is a combination of the subject being Federer and the object that is the tennis ball. And in a way, you can say both of those factors are being created in the very instance of the smashing. And that, in hindsight, could be called a collapse of the superposition that was before, the undecidability, or the thing that is not yet to be, not yet determined, not fixed. And that could be put in context with David Bohm's idea of implicit, explicit. And it looks a little bit like this, that the implicit is what is before we decide that Federer had smashed the tennis ball, which is the explicit. So the implicit is a little bit like the superposition, something not yet decided, but don't be tricked. There is properties in the implicit, but we don't know them, and they're not constructed in the way that we normally think. So it's a bit different. Do you have any viewpoints there? We had a brief talk just before this recording, and Henrik mentions something very interesting about the electron, because that was another quote we took from the book, The Holographic Paradigm of David Bohm. And there was a quote from Niels Bohr, who said that we should not regard the electron to be existing. That would be a property that would be outside what we can actually observe or think or compute about the electron. And he was very clear with this distinction. His son Åge Bohr was even clearer, and Åge is famous for barking at students who put in existence in their thinking. They need to get rid of this ghost in the mind, hjärnspöke, as we say in Swedish, brain ghost. Do you like to continue, Henrik, the path you started early on here, because it was so interesting?
A reflection from Kalle, who cannot talk to us at the moment. He said that it was the wrong book you referred to. It was Science, Order and Creativity. What's the name of the title?
Thank you. Okay. Thank you, Kalle.
It's not the holographic paradigm. And we would need that quote again. Maybe Kalle can write it to us or something. But after a previous discussion, I read it one more time. I reflected over it when I listened to the previous YouTube. That what you're actually saying is that we as a scientist, we are working with a system, a mathematical system here. We want to know what creates the photon. Okay, so the electron jumps from position 5 to position 2, and then we can measure the energy that comes out of it, and we call it that the photon. And all this is like a system of thought or something that we calculate upon, which in sense mean that this is not something that actually exists. This is another take on it, rather. That they are working mathematically within their formulas and their system of, what the photon is, what the electron is, what an atom is. And it seems to work when you compare it to empirically. Then.
Yeah.
And not to say that there are actually electrons. If we just have a magnification glass big enough, we would see an electron. That is not true.
No,
I think that was
the electron.
that's my point or take on this at the moment. We will see what happens.
Yeah, it's quite interesting, and I'm lucky enough to further this discussion with some other thinking from Bohr. And as you know, the atomic model was made of Bohr. He's the inventor of the atomic model. And the atomic model was something that I encountered in school. And we were, exactly as you said, Henrik, we looked at the different, how do you say that, the electron shells of the atom, and the electron is jumping when it gets excited. And I think all of us, we perceived this electron model, the atomic model, to be real in some way. And, and this was furthered by the teacher having a model made it plastic, where you have the neutrons were red balls. No, they were blue. And the positrons were red, I think, and the electron had another color. And then we had a sort of an atomic model. And later in life, I also saw a photo of the atom, and that, so to speak, that made it even sure that the atom exists. And then I read that Bohr said about his own atomic model, it's just a model, it's not reality.
I have the quote now here from Kalle. Bohr himself had emphasized that there is no meaning in talking about the existence of the electron, except as an aspect of the unanalyzable pattern of phenomena in which its observation takes place. So it is like twofold here. It's both that it is a model, and existence is something we cannot talk about either, or something. Either.
Yeah. And this I can't pronounce today. I'm sorry about that. Unanalyzable. Yeah, thanks, Henrik. The unanalyzable, it's the implicit, more or less, what we cannot perceive as a whole. We cannot take it as a gestalt, and that is what's lying beforehand. And the explicit things, the models, as you call it, Henry, that is what we should work with, and nothing else. And the same goes for the atomic model. It's a mathematical device. It's an experimental device, but you can't actually see the atom. Those photos that I saw turned out to be more or less fake. It's like you work with photography, and you can do like sort of a picture of an atom, but it cannot be seen in that way, not in the normal way. Partly because of the wavelength of the light, because it doesn't become it's not a normal object in that sense.
No.
And one could say that Bohr is actually on the specific border, both in history, like in time, in in the late 20s, the early 30s, but also in thinking process where we have come to some sort of frontier, and when we go into this frontier, we need to change our thinking somehow, and this frontier is, of course, what is reality as such. When they came to this frontier, they took different paths. Einstein, for instance, he could not leave the idea that there were actually things existing outside observation somehow, outside what you could calculate. And we of course, we need to understand, when we hear this quote from Einstein, the moon exists even if I don't see it, that applies, of course, even more to the quantum physical things. And it's from calculations. They found out that it's meaningless to talk about something to be existing without observation, without calculation, without measurement, and without all those things. And that goes for the electron, and that goes for the atom. But what I was thinking as a subject today is, like, we further that to even the macroscopic world, the world we're living in. What we will be doing is like a transference, like Schrödinger did. He took in his analogy, Schrödinger's cat, he took the circumstances, the relations from the quantum physical world, and transfer that to something macroscopic like a cat. And then he showed that this is how the microscopic world works, and now you can see it with your own eyes, so you can at least imagine it with your own mind to be a big object like a cat. And then we have this absurdity, we have this break. And this is the frontier, I would say, the frontier. And that raises a whole box of questions. And one question I've been thinking about is we get a new reality when we pass the frontier. Bohr was obviously living in a new reality and a new way of thinking. And that is real to him. But what are the things that makes the former reality to be perceived as real? That's also very interesting, because Einstein, he remained in that reality. So there must have been things in that reality that sort of gave him indications for him. This is real. This is working. This is real. This is reality somehow, because all of a sudden those two people, and this is extra interesting because they met so many times, and they discussed those things in Copenhagen and also in Brussels. And in the end, Einstein sort of gave up the direct confrontational discussions with Bohr, because he didn't know how to sort of prove things to exist by themselves. But still, it must have been something that attracted him. What could those things be? I wonder. My idea.
But as we speak about David Bohm now, so he introduces this idea of implicit and explicit, right?
Yeah.
So implicit, we can almost call it knowledge, I think, or something, or imagination, or whatever. So implicit electrons exist, right? And explicit they don't. Is that?
I would say that's very fair. Well, very fair to say that. I would say that. It's not analyzable. It's unanalyzable. But that's existence to Bohr. And that of course is not existence in the way that Einstein was hoping for.
No, because they only talk about the explicit, right? It's only what is, so to speak.
Yeah,
There's
exactly.
no knowledge
exactly.
or no memory or no history, which we have implicit, right?
No. Yeah. I think one
Science today
example
has like taken away all those ideas of knowledge.
Oh yeah.
There is no knowledge in physics, right?
No, not as such.
There's only hard
I think
facts.
one good, hard facts mentioning that. I have an example here, and one thing that Einstein would have liked is something we call independent neutral observations, like different experiments made maybe by different people, they come to the same conclusion. And that is very important for Einstein. And that's one of the traits, what he would perceive to be real. Yeah. If reality can show, reality should have these traits.
Yeah, the same pattern irregularity shows when different persons test. They does the same
test. Yeah. And there you have a very decisive disagreement with Bohr. Bohr says no to that, and that thing never happens in quantum physics. You don't have independent, situation independent observations, and that's a demand from Einstein to say he really needs that, and he cannot get it, and therefore he continues to be in the old reality, and that's a very important thing for many people. It's like almost like a thermometer for what is real. Do you have these independent observations by different people at different instances? Then it's reality. It's like a water stamp for something to be real. And quantum physics doesn't like that.
No, because it says don't involve me in this measurement at all. There is some objectivity here going on.
And that's very decisive. That's very clear example of something that is in one of the physics and not in the other physics. Actually, in quantum physics, there need to be a subject, always. All the observations should be sort of directed or intentional and not observer independent, as it's like a very fancy term for classical physics. And that's extremely interesting, because I think that latter thing is what normal people, like everyday people have, like laymen, like myself. This is what I would say is reality, because that's ingrained in how we think about reality. And if you open a newspaper, you will read this experiment, it was biased, that's a bad thing. Here we have a subjective ingredient in some observation that makes it bad to be of a lesser quality. You need to be objective. That's sort of interesting, isn't it? The difference is huge. It's actually huge.
Don't involve me in our relationship.
No, something like that. It's like the real thing is that that is not man-made. It's not constructed by human man. And I think the same goes for mathematics. A lot of people within mathematics, they want mathematics to be non-human, so to speak, existing in some sphere outside human cognition. And of course, those mathematicians, they also say that there are existing numbers somewhere that nobody will think about, nobody will calculate, but they still exist. can hear, those people are going in the exact opposite direction of Bohr and, well, more or less of Bohm as well. So they say there are existing things that nobody ever can observe, which is completely weird. Even I get a feeling that is really weird. There was a famous mathematician called Bishop. He called that, if you say those things, you're suffering from schizophrenia, and he might have a point there. It's really bad. It's really bad.
But what about religion then? Heaven and hell? Would they
Yeah.
not be real? if we can't observe them or something?
Well, I think religion would. I'm just going to throw something into the basket here, and I think religion would say you can observe those things. Yeah.
Yes, you could.
Got a comment from got a great comment from Kalle there. Could you read that, Henry?
Thus we can save existence. No, sorry. The moon only exists implicitly before we observe the moon. It is an unanalyzable pattern of phenomena. Thus we can save existence. We have existence implicitly. Why not do a compromise? The numbers exist implicitly and as a potential. Yes, as long as there are humans, I would say. But some mathematicians say that numbers exist without any human beings at all.
Yeah, I think that's very good, Kalle, because those mathematicians, they say that numbers exist explicit. So something have observed them. And what that is, they won't say. But I have a friend who is a mathematician, how do you say it? He is a realist when it comes to maths. So he says those things exist really. And when I ask him, and who's observing those numbers, and who's counting on them, and who's thinking them, and that he can't answer. But they still do exist. That's what he says. And he looked at me sternly. They do exist. I know that. And my question is, how do you know that?
Yeah.
How would anyone know that? But yeah, definitely, numbers have an implicit existence. And when you mention religion there, I would say that religious people really means that those things exist, and that could be implicit then. But whereas a mathematician, he means that the numbers exist explicitly, like
that's a difference.
By being, there's a difference there. I would say that's a difference that in the beginning sounds like splitting hairs. If you know that expression, it sounds like hair splitting. It sounds like something insignificant. But once you discover and learn to understand this difference, it becomes progressively important. And this is the actual difference that made up quantum physics. So it does have an importance. It's not just a play with words. This is extremely important. David Bohm, in his books, I should say, I mentioned the holographic paradigm, but the book we were talking about here was Science and Creativity, Order and Creativity, maybe it's the. And in both those books, he tried to show what is the meaning of these two new expressions, implicit and explicit, because they are very strict new words invented by David Bohm, but they are extremely helpful. And I would recommend people to sort of practice them and learn their function. And you have different examples in the book. I remember one, and it's like you have a big jar of glycerine. Do you know what that is? It's like sort of sugar alcohol, which is very dense. It's like syrup almost.
What was the name?
Glycerine. Glycerine.
Oh, glycerin. Yeah.
And you put a drop of ink in that glycerine jar, and the thing is, you can move it. You can make it move circle-wise, spin. And what happens with the drop of ink, because it's so much less dense than the glycerin, it becomes thinner, 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 and all of a sudden it disappears. You can't see it anymore. But if you start turning the jar of glycerine backwards from the direction you from the beginning turned it, the drop will miraculously appear again. And that's an experiment you can do. And this is sort of a metaphor for to understand the difference between implicit and explicit. So you can say the drop always existed implicitly, but when the drop appears for your observation, for your thinking process, for your whole system, for your whole body, it would be explicit.
Would you? Let's rewind. The drop reappears in the glycerin, right?
Yeah.
So there is some kind of memory or something implicit in the glycerin that allows it to emerge or something.
Yeah, you can say that,
or,
because the drop. Yeah, you can do this experiment, and it's quite amazing. I think I saw a video about it for many years ago. I don't know if the experiment is on YouTube, but if it is, I will find it and put it there. You could call it a memory. Yeah, you can call it a memory, but the drop, the metaphor only goes so far, because in a certain way, of course, the atoms of the ink are literally in the glycerin, whereas if something is truly implicit, you cannot take the glycerin and the ink apart like that. But the metaphor still holds. It's pretty good anyway. It's pretty good anyway. And this is what Bohr calls unanalyzable reality, or electron, or whatever it was. And that's very. This is here you can see that Bohr and Bohm are very similar, very similar. And I would say this implicit, explicit, it's very good thinking tools to understand what Bohr is saying. It helped me a lot because it gave me something to put into my head, into my mind, and we need that to understand these things, because we can't do the math, and the experiments look at them. That simply won't be enough. And so in the end, what we have to do is trust, which I of course do. I trust Bohr and I trust the quantum physicists. But in some way, I need to understand as well. And what Bohm does, David Bohm, is he provides us with these metaphors that makes us in the end understand what is implicit and what is explicit. But nota bene, the metaphor is not 100% exact. It's not 100% correct, but it's correct enough to give a feeling for what implicit and explicit is. Does that make sense?
Yeah, as a way of thinking, yes. I'm not really sure what implicit means. What this implicit thing is.
Yeah, one need to train one thinking, but this is similar to when some mathematical examples. When you get the example, it's not 100% correct, And that also goes for language. When you learn language, you will get examples, and they're not 100% correct, but they're extremely helpful in learning. And this is the same thing, because of course you cannot have an example from the real world where you actually can have something that is 100% implicit, because implicit is something new. We don't know about implicit until we learn about it in the books that David Bohm wrote.
Yeah, Kalle writes here, implicit means hidden.
Yeah.
So if it's hidden, we cannot observe it either. It's not like
no,
subconscious or something, maybe subconscious.
Yeah, and if we make it unhidden, then it's going to become explicit. And I mentioned that in example with gravity, and that gravity in the 15th century, it was the will from an object to come to the ground. It wanted to come to the ground. That was just Aristotelian physics. And then starting in the 17th century, there was a force dragging the object to the middle point of the Earth. And then in 1910, you get curvature in space-time. So all those things are different explicit takes on something that is implicit, and that's simply something falling.
Yes. So I'm just thinking, is there a cycle going on here? Like implicit becomes explicit and then becomes implicit.
Yeah, definitely.
So there is like a learning, some kind of learning cycle going on. Because I mean, the explicit becomes like knowledge, just like you said, the drop in the glycerin. That was something explicit. The water was there, and then it reappeared. So so the drop became from the explicit back to implicit or something.
Yeah,
explicit. There's a cycle going on here. It sounds like.
Yeah, it's a movement, and this is what David Bohm called the hollow movement. The hollow movement. And there's a movement from the explicit to the implicit to the explicit, and that's the hollow movement. And it's a little bit like, I don't know if you know about the French philosopher Henri Bergson, and he has this élan vital, and it's similar to the hollow movement, I would say, but that's my take on it. Don't trust me in this case. But the hollow movement is reality, and it's a sort of original movement, and that was one of the reasons I thought it was such a good idea to have the ambigram as a symbol for this channel, because the movement between the two visions you get from the ambigram, that movement is the hollow movement, and that is before something becomes something explicit. So you have an original movement there, and it's very interesting. It's so interesting because this movement is not a movement in the ordinary sense, because when you switch from one perception of the ambigram to the other, there is no movement. Nothing is moving in the regular sense. And somebody can say, well, the movement is in my mind. Well, the movement is both in your mind and in the ambigram simultaneously. But you don't move your eyes. You don't do a focus change in your retina or anything like that. There's no perceptible ordinary movement. It's something more fundamental from which everything moving and permanent comes. Isn't that great?
I'm just reflecting. This implicit thing becomes bigger and bigger. Is it a learning, something that or is it constant all the time? Nothing happens. Like it's a back and forth between explicit and implicit.
No. Yeah.
There is some kind of knowledge back or something. It sounds.
Yeah, like that's the whole movement.
That grows.
Yeah.
Would you say that it's a growing thing over time?
Yeah.
Or is it something that has always is deterministic or already ready? But there is no. There is no.
No.
Everything is fixed at the beginning. It's just a play between explicit and implicit. Or is it something that learns or evolves or something?
Yeah, it's the latter. The whole movement is constantly becoming bigger, more expansive.
Because you said it doesn't. Nothing happens. We look at the picture and it just goes back and forth, but it's still and nothing changes really, or something.
No, there is a movement, and that movement is more fundamental. So from a perspective of me looking at the ambigram, nothing happens. I'm just changing between two different views. But the movement happens. The movement happens. And that movement is the whole movement. And that's constantly progressing. It's constantly getting bigger. It's constantly expanding. And the whole movement is incredibly interesting because when you get stuck in trying to understand quantum physics, the whole movement is very, very helpful.
All right, we got 2 minutes left.
Okay. Maybe Kalle has some finishing thoughts on the prompter.
It was interesting. Movement between knowledge and not knowledge. Non-observation. So, but at the same time, knowledge expands. Well,
yeah.
So we have been discussing mostly David Bohm now. Wasn't it this Federer example we should have talking about instead? I don't know. The Federer.
Well, yeah, but it goes hand in hand because this explains what happens in Federer. It explains that there is something implicit, but the explicit is him smashing the ball. And this is what struck me when I heard this example from Roger Penrose. That was the best explanation I ever heard about what is the collapse of the superposition and how come when I look in hindsight, it looks so different.
So whole movement is that the collapsing of the superposition then? This movement between implicit and explicit?
Yeah, exactly.
It is that is we're talking about superposition. Okay.
Yeah.
All right. I think we don't have much more time now at the moment.
Okay. Well, thank you very much. It was a very pleasant talk.
Yep.
And let's hear again. It was very nice. Okay, take it easy, guys.
Take it easy.
All you out there listening. Bye-bye.
Yeah.